just prior to the meeting, we were talking about the fact that both Pedro and Ben are extremely popular individuals right now as AI has become incredibly interesting and very relevant, really in all aspects of our life, whether that's socially or and certainly professionally. So before we get started in the talking about AI today and how it's going to change all of our lives for the better, obviously, I just want to make a quick couple of comments about the structure of the meeting. So we're fortunate enough to have both Ben Lubkin and Pedro Teixeira with us today to talk about AI and how it's integrating into the rehab space. So this is how the meeting's going to go. We're going to talk for about 15 minutes. Each presenter will get about 15, 20 minutes to talk about their visions of AI and specifically their products. And then we're going to move to a panel discussion about AI. We've had some great questions from audience members. So we'd like to further that and stimulate some conversations through a panel discussion. And we'll take about 20 to 30 minutes to do that, okay? Perfect. So let's start with our first presenter, Pedro Teixeira. Thank you so much for joining us today. Pedro and Ravi Atira launched Prediction Health in January of 2017, a startup dedicated to helping clinicians and healthcare organizations understand and quantify unstructured data in their EHR with machine learning to ensure every patient gets the best care every time. Their analytics and actionable feedback in physical therapy help organizations improve their compliance and practice efficiency by analyzing every sentence of every single note. Pedro received his MD, PhD degrees from Vanderbilt University and completed his PhD in the laboratory of Dr. Josh Denny in the Department of Biomedical Informatics. There he applied machine learning and natural language processing methods to extract phenotypic information from electronic health records and identify associations with genetic variants. Pedro, thank you. Thanks for joining us.
Yeah, no, excited to be here. And so, happy to dive in. As you can tell, I'm kind of a huge nerd. The summary version of that. And hopefully I can use that experience to distill this down into something that's useful. So I thought I would start off with a little crash course I give on what is machine learning and artificial intelligence, because for a lot of folks, it just seems like this black box that's really mysterious. So I like to break that down. And then I have three specific ways, and I've done this, I've tried to make it a little bit fun, tantalizing ways that I think that AI and machine learning can do exciting things for compliance in PT, for CPT coding, and then finally answering the age-old question of will AI take our jobs, which we get that question, and I actually don't think there's anything to fear. But with that, I'll start with machine learning. So machine learning you can really just think about as pattern matching. Stuff comes in, and then the model that you will train, a machine learning model, will have learned from examples and give you an output. Usually, the more data you have, the smarter the models get. But you do need usually a lot of data. And then you're not putting in rules, you're just showing it examples. So a really simple way to think about it would be if I describe something and then I ask you to predict what object this is, it'd be like, well, if I say, I have a cute fuzzy creature with a wet nose and a wagging tail, you'd probably think dog, right? And we've in blue there sort of marked some of the key phrases that are kind of cluing you in. And if I showed you many thousands of examples or maybe millions of examples of descriptions and then animals, you could have a model learn this. So maybe an animal that's bigger than a bread box with black and white spots and says moo. Maybe you think cow, right? So when you're predicting that next thing that before I hit the button to show you, you're kind of acting like a machine learning model. Cherry red with 4 wheels, a steering wheel, and zipping around windy roads. Maybe you think something like a sports car, or other type of car. So that was pattern matching. We give you an input, and then you predict some sort of output, like this little example with animals and then the car. So that's machine learning. Now, some folks will sort of combine or mix up artificial intelligence and machine learning, but artificial intelligence is a higher order thing. So you need to do pattern matching to be artificially intelligent. You have to be able to hear words or read text and understand what that means. But then if you can interpret and represent that knowledge and then reason about that knowledge, now that's when you're getting to artificial intelligence. For the rest of the presentation, I'll probably end up just saying AI to keep things simple. But remember, machine learning is the simpler, more pattern matching focused aspect. And then artificial intelligence is, again, going up this abstraction stack, this level of complexity higher, so that it can use pattern matching, but then to do more advanced things the way a human can think about things, reason, apply logic, etc. You'll also notice that some of the pictures in here are going to be from DALL-E. So this is actually generated by a machine, by a model that can take in descriptions of text and then generate pictures, which is another cool way to use AI. So it's a computer model, right? It's code. It doesn't have eyes or ears in the traditional sense, but that's not really a problem for AI. And they say that classically a picture is worth thousands of words, right? But how many numbers per word? Or in other words, the models have to take some sort of input, and the trick here is that the models are always going to get numbers. Now, pictures have pixels, right, and colors that can turn into numbers. But how does that apply to words? Because again, the model's not looking and listening with ears, right? It's getting inputs of data, right? So the punchline is that you can go from words to numbers. So here we have a classic sort of presenting chief complaint, right? I have low back pain. And each of those colored boxes are around words or pieces of words that then can be turned into numbers. Now, each of those pieces of words in the type of AI that like a chat GPT is, we call them tokens. So tokens, think about basically like a chunk of word. And then characters is just every single letter or space. So for like the word low, there's a number somewhere that represents it of 9319. It could be any number. Theoretically, you just have to be consistent. And you can apply that for a lot of words, millions of words. All of the words on the internet, for example, this is how they trained ChatGPT. They turned all of those words and pieces of words into numbers and then just streamed in piles of these words as numbers and then had the model predict what's missing. And that's, if you've gotten to play with ChatGPT, it can be quite impressive, right? That you just type stuff in, it seems to understand what you're saying and then respond back. And it's because it's taken words or pieces of words as numbers. It's seen many, many, like millions and millions, billions of tokens actually during training runs and has learned probabilistically that, when you say a certain thing, when I see a certain sequence of numbers, then this other set of numbers comes out. So here's an actual sort of example to see. So if I type PT is awesome, strength, balance, and coordination are critical to a great quality of life, then that converts into all of these numbers down below that represents 20 different tokens. You can see the exclamation point, right, has its own little token as well. And now this is an input to the model. It can sort of understand what that means from all of the different examples of things that it's seen. And now it can reply. And this is, I think, the coolest thing is that originally people didn't realize that if you streamed in consistently these numbers that represented words and gave it lots and lots of numbers, the models would end up having to learn very interesting things about the world and about language to be able to predict the next token. So when you go to ChatGPT and you ask it a question and then you're waiting for your response, it's trying to return what is the next most likely token that it would be expected in the sequence. And to do that, you have to understand language and the world, because otherwise you'd just be guessing, and the probability that you get the right answer is low. But if you actually understand what's being said, then the probability that you get the next things right as what would make sense as a reply goes up. So it's just like really, really wild to me. And we actually have a little bit of a HIPAA compliant ChatGPT in our platform. And so you can see, you're just typing things in. In this case, it was just asking for examples of exercises, right, to return in the table. And then this here that you see in front of you was spit out by the model. So here, give me some sets and reps to start with for a 30-year-old male. And now it's going to run, generate a table. And that table is, again, these lists of tokens and numbers that is actually responding to my question that I asked of give me a table with the exercises and then adding sets and reps. So really, really wild that you get understanding of the world from this approach. So that's the crash course on machine learning and AI, and the hopefully less black box now of an understanding for how you're taking words and things that you want, streaming it in as numbers, and then the models are learning about the probabilities of seeing these different numbers that represent the words, and then spitting out something useful, right, with regards to answering questions, explaining things. They can be tutors, and they can do a lot of cool things in PT. So So I said we're going to now apply this to therapy, right? So I made them a little bit like a clickbait title just for fun. But compliance auditors hate this one simple trick. It's actually a trick on my part because I would actually say that compliance auditors love this next simple trick. And that trick is visibility, because you can solve problems that you don't see. And because we've trained models to read through all of those sentences, specifically a PT compliance model, well, we take, again, words, we turn them into numbers, and then we train models to look at those pieces of text and understand what that text is. So here we're talking about aggravating factors in this case, and I'm highlighting the text just to show, to illustrate that, like, oh, certain parts of this sentence are going to help the model understand what is being said. Now, this is just one little example for one sentence, but if you have models that can read through all of the sentences and identify what's being discussed and compare it to what you need to discuss for it to be a good, thorough, and compliant note, well, now you can run it on every single sentence and every single note and get visibility into every single note. Once you have visibility into every single note, you can start doing some really cool things. So I have a couple of graphs here that are run on many thousands of notes, and we could do millions of notes, but for the sake of time, we'll just focus in on some examples here. So this graph, bars, the vertical height of each bar is how many notes were in that chunk. And then the color and the line represent the compliance score. So as this line goes down, left to right, it's showing that the compliance score is decreasing. As the color gets less happy, more red and orange, it's also indicating the compliance score is getting less good. And the x-axis is going from 0 hours after the visit to 200 hours after the visit, and it's showing the sign-off time. And then so you have these big tall bars here on the left, because a lot of people do sign off their notes pretty quickly when they finish their visits. But then you can see some folks take a little bit longer. And you'll notice that the compliance scores seem to get worse as that time goes by. So waiting to do notes doesn't seem to correlate very well with compliance scores. And this is something that we can see and visualize here, because again, we're not doing 6 episodes of care per year. We're doing literally every single note and looking at every single sentence. So that's not a very surprising trend, but it's really exciting to see, how much, it does kind of dip as you go out and take longer to sign off on a note. This is the first sign off, by the way. So what if we look over the course of a day? So let's just look, is it, let's say 5 a.m., is it 10 a.m., is it midnight, right, when we're signing off the note? Again, the color here is representing the audit score. Green means it's a better than average audit score. Red means it's a worse than average audit score. We've also shown the line here, so you can see audit score just kind of going up and down. And the height of the bar is also the number of notes that were signed off at that time. And now we see that there's actually also patterns across the hour of the day with regards to compliance. So largely better compliance during, let's say 7 a.m. out to 3 p.m. And then you see it starts getting a little bit lighter green, and then it starts getting pink, and then it starts getting red. And 2 a.m., that bright red little box there, not a great time to be doing notes. But again, just as an example of how we can see how compliance varies with regards to a lot of other things, because we're able to run this at scale for such a large data set, we can look for these kinds of associations. And this one's kind of fun too, because if I'm guessing why the compliance scores start going down at 3 p.m., I would wager it's because the coffee is maybe starting to wear off a little bit. Anyway, so that's compliance, right? And there's lots of stuff that then you would say are maybe related to compliance, like how long the note is. So here we have now the x-axis is the number of characters, right? The number of keys that they've pressed on the keyboard to generate a piece of documentation, excluding the template. And then on the y-axis is the audit grade score. So you want to be up high because you want to have a good audit score. Each color is representing different providers. So we're just showing a subset so you can really hone in on the different patterns. And we see there's kind of these clusters. Like here's a cluster of green. So this provider seems to kind of score in this range usually. They're usually writing pretty short notes, maybe just a couple hundred, words in there. And you see that as they're adding words, they're kind of sloping up towards being a higher audit score. So they are maybe being a little bit too brief in their notes. And if the note's really, really, really short, it's hard to get a good audit score because you do have to hit certain things. But at the other end over here, like 20,000 characters, that's a miniature novel that we're writing there. And that's probably not necessary. And you can see as you get really long notes, like, yeah, they're getting good audit scores, but how long are they taking to actually write that note? So we think that there's a bit of a sweet spot. You basically want to get maybe, let's say, around 5,000 characters is plenty if you know what to put in the note to get a good audit score. It doesn't guarantee a good audit score, but it allows you to very efficiently hit the key details that are necessary for a compliant note, have documented it thoroughly, but then save time. You don't need to write a letter, right, or a novel. You can just write a much more focused note and get a good result. And you can basically could save some of these people like 70% of the typing because they're writing overly long notes. And we all know that burnout's a big issue, over documentation is a big issue. And actually in our platform, we show this compliance score related to length. So the folks can talk to therapists that are maybe just spending too much time, and maybe they're spending that time at 2 a.m., right, doing the note, which doesn't really help them out. So does short mean bad, necessarily? And so here now we're showing the length of the note is the y-axis. And then the compliance score, we're coloring the points by the compliance score. And then we're also now showing sign off. So we're taking all of those things together in this graph and showing the three things combined. And you see that as you go out and sign off, we saw that the compliance scores get worse, and they do. But it's not because people are waiting to write their novel, 4, 5, 6 days later. This is actually on the x-axis out to 700 hours after the visit for getting to sign off, which we know it's not even the maximum time that happens. But you can see that, they're kind of ending up these brief notes. They're just trying to maybe knock out, and they're also not very compliant. So increased compliance risk, maybe, doing them a little more quickly or a little more in a rushed way, right? Short notes, not very good. But anyway, pattern matching, applying it at scale, and allows us to sort of look at the data in a lot of interesting ways that I thought would be kind of fun to synthesize. But anyway, taking a long time to sign off or writing super, super short notes, a little bit risky. There's a sweet spot that can be had.
Well, I was saying here that I was hoping folks would guess what the appropriate story is that matches the CPT coding. I'll give people just like a moment, right? But there's a story that comes to mind whenever we talk about CPT coding, which is Goldilocks and the Three Bears. And that's because, of course, the porridge is too cold, the porridge is too hot, that's no good. You want it to be just the right temperature. Similarly, CPT coding is you want that to also be just right. You don't want to undercode or overcode, right? Opportunity and risk options. And I was saying with this slide, these pictures here on the left are all AI generated. So I just typed what's here on the right, a little blonde girl named Goldilocks standing surrounded by three bears in a cheerful children's book pencil art style. And the AI model then generated these 4 images. And I was just really impressed by it because I think it really nailed it, except for the fact that I couldn't get it to generate 3 bears. So apparently it's Goldilocks and the 2 to 5 bears, but definitely not 3, because it can't count well, and just highlights how AI can be great at a lot of things, but not everything. And counting, for some bizarre reason, is one of those right now. So this aligns to CPT coding, right? The too cold would be opportunity. The care, you're doing care that is then not getting coded for. So maybe it's a TheraAct is what you're doing, but you're just coding a TheraX. If it's too hot and there's risk, you're coding for things that you're not justifying in the documentation. Keeping in mind, of course, that the models can never know what the intent of the therapist is. We do have to go by just what's in the documentation. So you want it to be just right, and accurately document what you're doing, and then accurately code for what has been justified in the note. So, opportunity example would be lunges and split squats to improve ability to transition from floor to standing. Now, we see this, literally, this type of example where it's marked as TheraX, when that could be a TheraAct, and vice versa. We've seen things like warm up on treadmill for 15 minutes that get marked as TheraAct, which, really is maybe more justifying just a TheraAct. Now, because we've trained models, and here's another example, right, that you can see, and even with the abbreviations and the crazy things that people will type, you can have the models learn, again, to do the pattern matching and the understanding of what's being written dynamically to then figure out what's an appropriate code to consider. And there's usually a lot more opportunity than risk, something in the range of almost like a 3-to-1 ratio. So maybe 64 units per provider per month of opportunity on average, 19 of the units are maybe risk, so 45 net opportunity units per month per therapist across a fairly large data set that we reviewed for organizations. Now, that makes sense. Folks don't want to get in trouble with the audit, but we should be accurate in what we're doing. So now I'll display in a similar graph hours to first note sign off. So on the left, it's everything that was done within the day. On the right side is things that took more than a day to get signed off. And this is green if it's low risk and red if it's a higher risk. And you can see that overall people are kind of stable. Very early and very late, the risk seems to increase more. And then on the subsequent days, there seems to be more variability with how much risk there is. The other comparison that you can do besides that, right, is of course the opportunity. Does that have the same pattern? And now we see a different pattern, is that the opportunity seems to be more evenly distributed across the hours of the day, and also even sort of like on subsequent days. We think this is potentially because if you're coding things, you're usually actually pretty consistent in how you code them overall. The question is then, did you accurately document it, which could influence the risk component? But then also, like, there's an educational component here where people, I think, just consistently do things the way they do them, and they don't realize that maybe there's an opportunity to shift. But because the model can read all those examples, it can really hone in and show that. So the last thing I have is just, will AI take our jobs? And I would like to think that instead it'll take things that people don't want to do, right? Maybe help with the documentation, maybe get rid of peer reviews, as we showed with that compliance example earlier. And this reminds me, back when I was in med school, I had great professors that would say, if you really want to learn about the patient, go see them. And when you're in the room, there's so much more that's discussed. And I like to think of every single patient encounter or visit as like this little point in space. And some visits are more similar, right? Your mechanical low back pain patient of a similar demographics, they're like all kind of maybe treated in one way. But different mechanism of injury, is be very different, or a different body part is of course very different. And I think that AI, the same way it can take words and convert them to numbers and learn patterns, can take entire visits and turn that into numbers and patterns. Here's actually processing the audio from a visit for an earlier experimentation that we did, showing how like you're doing your history at the beginning, then you're doing your exam in the middle, and then at the end there's a little bit of almost dictation style content to get things done. And you can understand what's being said. You can pull out keywords, and hopefully you could actually help people document. And I know we'll have a great presentation here in a minute, diving into one of the options, right, to do that. And it's definitely something that we've looked at as well, right? Because that's one of the great things I think that AI can do for folks going forward, is to help take some of these administrative things, documentation things, and read the content, because it's shown that it can read a bunch of text and output useful things. And just a rough example of how you could potentially take subjective, objective information, et cetera, and synthesize, an assessment, or potentially just take audio and synthesize the whole note. And I think that's a really key thing and very valuable tool and use case for AI in therapy. So we went over the how and what. We went over how compliance is already getting help in AI or by AI, how CPT coding could be enhanced by AI models, and then finally just helping with documentation to free therapists up to focus on their patients. And we've got a lot of effort and value, I think, from all three of those things that we've seen as a company, and excited to see how things progress further, and looking forward to questions later today. But with that, thank you all very much, and apologize for the technical difficulties there. Happy to answer questions in our panel portion later.
Pedro, thank you. That was incredibly interesting and insightful for me. I feel like I just got a crash course in AI and everything I needed to know about how machine learning is supposed to work. So I'm definitely interested in hearing more about how that is being applied from both yourself and from Ben to PT. So can't wait for the Q&A. And just as a reminder, guys, please feel free to put your questions into the chat so that after Ben's presentation, we can cover some of those questions in the time that we have remaining. So let me introduce Ben Lupkin. Ben is the CEO and co-founder of Tapt Health, an AI ambient documentation software platform for physical therapists and rehab professionals. Ben approaches physical therapy innovation from the perspective of a patient as well as a technologist. He most recently led a connected fitness integration program at Peloton and has attended over 500 PT sessions due to a rare genetic bone disorder. So Ben, thank you. You certainly have quite a bit of insight as a patient, and it sounds like you're going to have quite a bit of great input into how to make our lives easier. I think that's at least the way I see it, and I think many others see it. Just the pathway moving forward for AI in the rehab space is how can it make our lives easier?
Yeah, absolutely. Thanks, Frank and Rehab Council, for having me. It's allergy season in New York, so last night I started saying something's funny, so apologies if I'm a little scratchy. There's about to be a lot of beautiful cherry blossoms though in Central Park. In terms of, thank you, Pedro, first of all, as an academic. I'm more of an industry guy. Thank you for doing the technical explanation of ML to AI. I think it's really fascinating. I mean, Pedro and I come at it from two very different angles. Right, Pedro got a very specialized skill set and transitioned that into prediction health. I was just trying to figure out a way to make physical therapy care better for both the patients and the providers. And it was a long and windy road to get to ambient. I was at Peloton. We were building strength equipment, really exciting hardware that I was trying to translate to the clinic. And about a year ago, I was learning about the space and finding there was absolutely no budget for cool, sexy new hardware that would make patient care better and therapist care easier. And as I was needs finding in the space, learning about the industry, the thing that kept coming up over and over again is documentation time. This industry is kind of blighted by dropping reimbursements that are leading to rising utilization targets, and a pesky insurance industry, like Pedro is saying, that's trying to audit more and more nitpicking coding and needing justification, and kind of creating the incentives that make prediction health a true necessity product for providers. At the same time, ChatGPT hit the scene. And so I think what Pedro didn't say is there was an inflection point a couple of years ago in AI where going from the ML to the AI and the models got super powerful, and ChatGPT is just one of the most visible reflections of that, but it's happening all over industry right now. And so learning about these incentive structures and challenges and burnouts and turnover problems and seeing these technologies at the scene and being part of some tech circles. Fortunately, I've been blessed to be part of Silicon Valley and have a network of Silicon Valley experts. That was the why now of starting Tapt Health with a real mission-driven goal of helping providers, and by helping providers, you're helping patients, because kind of cookie-cutter factory mill care is not doing anyone any good, and no one's going to avoid the surgery if you're not really getting thought of by your provider because they're just so burned out. So with that said, now, what's the problem that we're looking to address? Right, I said it earlier, right? Documentation's both causing burnout, right? That's the most visible, but it's also reducing billable units. And so, while prediction health, I mean, Pedro, I'm just going to be comparing, contrasting. Second, right? One way to look at it is how do you do the best with what you have? And so, prediction health is taking what you did with the patient and is making it the most efficient and the best reimbursement for you. We're trying to increase the numerator entirely, because when you're spending so much time documenting and right, you can reduce your time, but what if you mostly eliminate your time? And by ambient means it's recording the sessions. It's recording the whole visit. You're doing active dictation. We're empowering you to treat like an orthopedic surgeon would. Like you see an orthopedic surgeon and they're coming in a room with a nurse practitioner or a PA or whatever, and they're just talking. And the PA is typing, or they're using a scribing service and they're typing, and there's no text input at all with this ambient. And yes, it's a little bit of a behavior change, and there's a natural curve of early adopters and mainstream, but a lot of therapists are getting the hang out of it. And when you can do this, you spend more time treating. For example, an eval visit, a 60-minute eval visit, maybe you get 1 or 2 CPT treatment codes. When you're talking through an eval, that eval is going 15, 20 minutes faster. That's an extra $30 of revenue per eval. It's $600 a month if you're seeing 20 patients a month, just by treating more efficiently and increasing the numerator of possible codes that you can bill, and then using prediction health afterwards to help optimize your coding. So hopefully that is a little bit of a contrast. I really am honored to be talking next to Pedro. I think these are very complementary products. So how does it work? The first thing you do is, like I said, it's ambient, you're recording. Obviously, in recording, you need patient permission. Medical recording laws require patient permission. The laws right now allow for verbal consent once a year. That's how the law is written. You usually, I mean, we've seen 99% of our patients agree to it when you tell a patient that you're going to be focused on them, right? Your eyes, hands, and ears are focused on them and not your laptop. All but the most privacy-minded patients will approve of that recording. You notice I'm wearing a lapel mic right now. It helps my audio quality, but it also means that as a therapist in a loud, busy clinic floor, I can do 2 things. I can move around and not have to worry about dragging my laptop close to me. And it also means that if, and this just happens a lot, if you're a clinic that's blasting Taylor Swift in the background, we're getting more of your voice and less of the music in the background, which is a big difference. A lot of the other ambient companies in the physician world, they're used to quiet private office settings. and we've had to manage tech stack around how to deal with crowded clinic floors. So that's the first step. You record and I'll have a little demo video of overviewing the 4 steps in a minute. The second step is, right, recording a visit is kind of like, Dragon software or Nuance. It's just creating a transcript of unstructured data. And I like, the discussion of, right, unstructured to structured. It's kind of reducing the entropy, if you use a physics terminology of the information you're presenting. And so if I'm in a visit and it's a 45-minute conversation, there's going to be subjective tidbits, objective tidbits, right, assessment, treatments all over the place in that visit. And there's going to be a lot of other information, like, right, physical therapists, it's a very social profession. It's not efficient like a physician visit. You're going to be talking to the patient about their life, about their hobbies, right? There's a lot of extraneous information. And so the magic of AI, which right, ChatGPT kind of brought in, is because of that predictive ability, it's able to do a very good job of structuring very, very unstructured information. And we further created kind of an EMR backend to know what a note looks like, to be able to even reduce the entropy more than any competitor. So if you were to look at, right, I'm going to basically take a 45-minute transcript and push it through ChatGPT, what you're going to get is 4 big paragraphs of text. And it's maybe going to have what you need, maybe not. Maybe it'll include relevant things. I mean, right, we're reducing the entropy a lot more and getting it structured. So, right, the analogy to, right, what Pedro was saying about, are you including, aggravating and easing factors as justification, right? We're making sure that each one of those individual fields is pulled out of an audio transcript or a dictation to make that note as compliant as possible for you to just be able to submit with, right? I mean, what we're saying is, this is not 100% no, right? AI is not replacing you. We're not a medical device, right? Someone's going to eventually have AI as a medical device. They're going to spend $100 million trying to get that through the FDA. That's not us. We're augmenting you. We're getting the note 90% of the way there, and then you're going to spend the last 10% of time reviewing and then being the one to sign off on it. And then the last important step is, we realize that the EMR right now is the kind of limiting factor of most workflows, right? You're not going to be able to use us to just replace your EMR. You have to get the data into your EMR. And so what we've done is 2 pathways. For small and medium business customers, we make it really easy for transfer. And then for enterprise customers, we're automating integrations so that when you finish a note and you sign off on it in our system, or not sign off on it, when you finish the note in our system, you're going to then see the note in your existing EMR so that you can sign off on it in the EMR. So those are the high level 3 different tech steps. Each one's a different technical process we developed. We're a much newer company than PredictionHealth. We were first in clinic in August. And so, we've been doing thousands of visits, not quite on the order of millions. But we're learning fast, and we have some battle testing. So let me do a little bit of a video. I don't know if the audio can come through. So as I was saying, the first step, right, you just create a patient, super lean implementation. Second step is just pressing record. We're generating a transcript, just like any other transcript. When you're done with the transcript, you then build it. So our AI does 2 things. It figures out the region of the body, and then it basically builds to our templates. And then the last thing is you're reviewing and editing a fully structured note. And so if you're looking at this structured note, you're looking at it in a format that's a lot more like your EMR than a big GPT blob. And each field can be individually editable. You can edit in our system. The editing can improve our AI even more. Adding fields, replacing like tidbits and sentence structures. Where we just released flow sheet functionality last week, and we're going to keep improving that. So to make it really easy to review everything and recode yourself. And so that's a high level. So what's happening right now with our customers, right? One, more billing. So we've been tracking with one of our customers who actually does advanced KPIs of their clinicians, and they're tracking the number of additional units per eval that they're getting. And this was a clinic that already built a lot, so they already did eval plus like 2.5 CPT codes for treatment during that eval, and now we're getting them to 3. If you're a clinic that's doing 1 treatment code, I mean, we're very confident we're going to get you to 2. We're going to get you that extra treatment code and more billing, and that's what immediately can create that ROI, right? Like, I think this is one thing to say. Like, the thing that we struggle with a lot is burnout is a hard thing to sell. It's a hard, right? It's a salaried employee who is there's a moral hazard element, right? Where you're paying people salaried. Their burnout is a long-term risk to you. Like there's a lot of cost associated with burnout, but maybe that's 6 months, maybe that's 12 months. How are you justifying a cost center when you're not sure for a year or two if it's actually helping you? And that's why we like to, to show that the evals are more efficient and that you're getting that, month 1, month 2 return on investment, and then the burnout improvement is coming down a year or two later is going to be that long tail that's really beneficial. And then, like I said, patient retention. We haven't, gotten long enough data sets to track this over time, but what our providers are saying is that their patients are more engaged. That there's two benefits. One, talking through an eval. I mean, there's going to be some patients who are hypochondriacs, and there's going to be, perhaps that's a risk for the special populations. But for a lot of patients, they're more engaged in their care. They understand what's happening in their body. The therapist has a lot more time to talk and focus on engaging them. And there's this problem in PT where from the eval, there's oftentimes a high drop off to the second visit. And why is that? It's because the first visit was just an hour of going through with the goniometer and taking measurements and assessing you, and then maybe you do one exercise. And let's say I'm like, I took out time off work. It was really hard to get there. Right, the first visit I saw very little improvement. And now with a system like this, not only is the eval more interactive, but the treatment is more aggressive in the first visit. That's going to improve the retention and the lifetime value of your customers. And so, a couple testimonials, happy providers with the system. Okay. Let's see, is that the last slide? All right, I think that may be the last slide I have. A much shorter deck, but that's who we are. I wanted to leave time now for some Q&As from Frank.
Yeah, thank you. That was excellent. I think what both of you presented were tools that in the rehab space can immediately be applied, improve quality of care, not only improve quality of care, but improve reimbursement. And Ben, to your point, burnout, you described it as a long tail. I wish it were a much longer tail, like meaning we could keep our therapist around for 5, 10, 15 years. The reality is, I've been doing this for 34 years, and I've never seen a shortage like I've seen in the last 3 years in the field of physical therapy. So it is a real problem, and burnout is certainly one of the causes of that problem. So I think, again, both of you offer products that employ AI, and thank you so much for explaining it the way you did. Prior to this meeting, I was telling both of these guys that I'm not the most tech-savvy person in the world. So I think there's a general fear of AI based on a lack of understanding, and what you guys just presented clears that up for me. And I think that's the gateway to utilization, right? Talking about a lot of smart people who won't use something that they don't understand because AI is relatively new. I think that in and of itself creates the barrier. So excellent presentation. So I've got a general question for both Ben and Pedro, and that is, we know where AI is. We've seen where it was a year ago. Where do you see it going in the next 1 to 2 years, specifically in the rehab space? Ben, I'll start with you.
Okay, yeah. I think right now what you're seeing is more point solutions. So like when you start with machine learning as a model of just finding patterns to expanding on that to find solutions for point issues, it's solving individual issues. I mean, we talked before the call also about how interoperability is a problem. So you have these point solutions, they don't always talk nice to each other. The EMRs have some incentives to kind of keep their data locked tight because data is a big asset for them as well. And so I think the big way that AI can improve is when by AIs talking to each other and be more like not replacing you, but get closer to this like AGI, like a more general intelligence point because they're talking together. And I really think like my dream is solving this problem in physical therapy rehab where the value of rehab is not kind of shown with reimbursements. You have this data set that shows that PT can avoid surgeries. It can be the most effective use of musculoskeletal funding, but then you have incentives where reimbursements are flat or dropping, and it's incentivizing the wrong care. And so, my view of AI and how it's going to ultimately help, and I don't know, it's going to be Tapt or Prediction or another player, is looking longitudinally across, everything that's happening in a patient's musculoskeletal journey and saying, yeah, this is the value that we demonstrated that PT brought in overall cost of progression, and then getting kind of alternate payment models set up around the AI insights. That would be my dream for AI.
Yeah, I love that answer. And you can tell that you're coming from the perspective not only as a professional in the industry, but as a patient as well. And I think, Pedro, you're uniquely positioned to do the same as a physician. So it's great. Pedro, what would your response be to that question? Oh, having a problem with audio. Maybe you can just write it out, Pedro, and put it up on the screen.
Murphy's Law.
There you
Let me
go.
know. Yeah.
Yeah.
Murphy's Law says
Right.
everything's go wrong, right? I like to look at the future based on the tech trends, because I think the tech trends actually have been reliable, like Moore's law and compute increasing over every like 18 months, doubling roughly, right? So the AI models, we already have several years, right? For these large language models as an example, where they've just gotten smarter and faster and better and cheaper to run. And so if that's where the tech is going, there's certain things that you aren't going to use models for right now because it's too risky, because they might, hallucinate and say something that's incorrect. And so if they're going to get more likely to give you the right answer or a good answer over time or the next 2 years, then I think you're going to see more and more applications in healthcare. And the highest leverage point that we see is in the actual workflow for like when you're taking care of patients. And then again, also for then data analytics on the back end. So I do think that you're going to see more and more tools, initially maybe taking some of the burden off, but then I think being sort of symbiotically involved in the patient care and the decisions, not like making the decisions. That's like a whole medical device, like regulatory hurdle you have to jump over for that, but maybe presenting you with the information that's relevant. Like, oh, did you realize that maybe this person hasn't progressed their care over the last 5 visits as much as like your average, right? And telling you that in the moment when you're deciding what to do in that day, and then helping document it, right? Or on the back end, their accuracy is going up, the availability is going up, and then getting integrated into the system so that organizations can look at like, well, how efficient are we at taking a low back pain person like this and getting them to a good outcome, right? And then what's all the variation there? Because there's a lot of variation with regards to like total plan of care length, how many visits are needed, how fast someone's oswestry, improves. And I think you're going to see in both of those cases just more and more AI coming in, but not to like replace whole things. I think they're going to be coming in more as like another tool, the way like, electricity or computers came in, they let us do new things, but they didn't like replace, everything.
Yeah, I think that's a great answer. And it was interesting that I think that both of you made the comment, will it replace us? I can tell you that I speak to, and I'd love to hear from the other audience members. I speak to a lot of folks, and none of them are afraid of AI replacing what we do as clinicians. I think it's really more about how's it going to augment what we do and improve our lives and replace some of those administrative functions that we just are not fond of. We want to take care of patients.
Yeah.
Sherlocka, you had a question. I apologize, I missed that earlier.
Oh gosh, no worries at all. Thank you, Frank. No, this was a fascinating presentation. I hope you would do that I work for Innova Health System. I guess my question, either one of you can answer. I was just wondering, with competing priorities that we have with remote monitoring therapeutics right now, I mean, granted, that has nothing to do with what you presented. How are you going to the systems and helping them understand that this is a tool that clinicians truly need? Is this something you integrate into Epic documentation? Because Pedro, you said you have plenty of inpatient notes, but do you have outpatient notes to kind of predict the documentation? How does this work? I'm still a little fuzzy with the presentation. I hope you'll share the presentation. I hope you consider so I can review it again.
Sure. So we also have a large volume of outpatient notes, which is sort of key for PT. Basically, all of our PT is outpatient notes is our focus for that. And we are also building an integration into Epic. So for retrospective analytics, if you're an Epic site and you reach out to us, we have a set of folks on that like wait list for the integration just to go live, which we're working on. So then we have both sets of notes. And then, yeah, I mean, both sets of notes are really important for the models. As I mentioned in the beginning, machine learning model quality is largely affected by how much data you have to train them. Because there's a lot of crazy things that happen in the real world, and if you've never seen an example that's even kind of close to that, it's hard to do the right thing when you see another rare occurrence. So hopefully that answers most of it. Happy to do follow-ups if useful.
No, that's helpful. I guess I think Ben can probably answer the rest of the thing I was hoping, because Ben, you showed a lot of value proposition, right? Burnout, which I think is a great value proposition. But were you successful in convincing organizations, but by just using that word, or you had to do some more work to prove to the organizations that this is really effective tool?
Yeah, I mean, I think I'm going to go back to the kind of adoption curve of new technology, and I think AI, I mean, right, we're still in the first like couple of years where this is super powerful, and so healthcare is not always the early adopter community, and so what we found is, we have things called design partners, right? Like a year ago, we started working with very kind of forward-thinking people who needed no convincing. There were physical therapy clinics who were trying to implement scribing programs by using PT techs to be scribes. The problem they were having was the turnover was so high that every time they trained someone to be knowledgeable enough about PT notes to be a scribe, they would quit or they would move on. And even minimum wage laws is affecting a lot of that community as well right now. And so right now, a lot of our users are people who are forward thinking, right? The sales cycle of how do you convince someone that this is something you need really is, I mean, as eloquent as I think I can be sometimes, you can't incept an idea in someone that they need something that's a cost center that they don't want to hear. And so we're finding that most of the people we're talking to are people that are big groups that have innovation teams, people pursuing alternate payment models, people that have some reason right now other than just saying burnout is a problem to be working with us on this technology.
Yeah, that's great. Thank you,
There
guys.
there was an RTM thing that I'll just mention briefly. Some of the RTM folks, organizations will get the RTM tools, and then they are not necessarily able to track if they're getting good ROI on those RTM tools. We did actually do a webinar and a research that, some internal research, because we have some organizations that are using things like Limber, for example, and we can actually read the unstructured text to identify, okay, the organization has it, but these, let's say 5 therapists are not regularly using the RTM code, even though they're mentioning maybe doing some RTM stuff. So to the retrospective data point and to your question about RTM, we do have some analysis there, and I'm happy to send those resources along if that would be helpful.
That would be great, guys. And just before we get to Sagan's question, if it's possible for you guys to both put your contact information in the chat. So this is recorded, and folks can go back to that recording and connect with you if they have any other questions. Perfect. Sagan?
Hi there. Thank you. So just in general, is the AI learning from each interaction on an individual basis, or is it aggregated from client to client and retains that information and then learns how to treat an assessment like lower back pain or something to that effect? And then a follow-up to that is, are you retaining the data as the organization that it learns, the AI learns?
So it changes by model. The thing where it learns from every single example is called online learning. And it's actually very rare in production to see people do that because the new examples that you see may not be correct. So we do like batch training runs where we validate the data, we confirm it's high quality, and then the model does get updated. So it does learn from the stuff that we end up seeing, but there's a lot of process in between. It processes a case and then like when it learns and upgrades to the latest version. And then again, that's different per model. So it's not just like randomly changing, at least not for any of the models that we've seen or that we use. And then we do need to retain the data so we can improve it over time for the organizations, because since we do this iterative process, by gathering more of the data over time, the models are getting better for that organization and for others. But we, of course, apply everything's HIPAA compliant, highly careful, secure, and then de-identifying data whenever possible. Because usually, like patient names aren't very helpful to the model to do its job, so you can get rid of that kind of information, and then also reduce the risk of having any sort of PHI issue.
Yeah, exactly. So yeah, I'll add to that from our perspective. I agree. We're not doing a continuous like online learning, but what we are doing is our goal right now, and I'll tell you where we are now and where we are in the future. Our goal right now is, let's say we have a low back note, right? We're trying to make the most comprehensive AI for all providers, right? And this probably means, getting it 99% right, not 100, because there's going to be some provider that uses some special test that they use the wrong name for, and right, it's going to be very hard for us to get that. But we are batching learnings from the corrections and continuously improving, right, our templates that inform our structured notes. The next level, like Pedro was saying, like every year it's getting better and better. We're not far off from kind of having truly custom AIs, like people who say that they learn your style right now are doing something called model like fine tunings, or they're just putting example notes into a prompt of like a ChatGPT analogy. The issue with that is that like hallucinations rise a lot. And so, we believe that people that are claiming to overfit your style are also risking, over hallucinating on models, and quality matters more than style. We have had a few kind of OCD, like truly OCD therapists that can't get over the fact that our styles don't match, but the vast majority of them are more worried about just data quality. In terms of training, we allow you to delete visits in patients, but like Pedro said, by default, we're not deleting it because we're fully HIPAA compliant. We're working on even more than HIPAA compliance from a security perspective. But that data, if you don't delete it when you remove PHI and strip PHI, which removing PHI is a very solvable problem, it's solved in a very low risk way, will enable us to make even better and better rehab models. For enterprise customers, we are in sales contracts where we're not allowed to store anything, and it's a big concern for some big systems, and we're not going to let that be a reason not to sign a contract.
Great, thank
Appreciate
you. So I think we've got 2 minutes, possibly not enough to take our next question. I've got a list of questions. Anybody's interested, or Pedro, Ben, if you have the time to hang out and ask any other or answer any other burning questions that they may have, that'd be great, but certainly understand if you don't. I'm going to thank you both for your time. Fantastic discussion. Thank you both for taking the time to present and for engaging in a panel discussion. Like I said, I've got a laundry list of questions, and I'm sure this is information and questions that will continue to go on for years to come. So thank you both.